Today, we're going to explore the beginning of the universe and beyond. We are going to talk about one of the most fascinating and fundamental questions in science. How did the universe begin? The universe is everything that exists, from the smallest subatomic particles to the largest galaxies, and all the space and time in between. But where did it all come from? How did it all start? And what will happen to it in the future? These are some of the questions that cosmologists, the scientists who study the origin and evolution of the universe, try to answer using observations, experiments, and theories. The most widely accepted theory of the origin of the universe is called the Big Bang Theory. According to this theory, the universe began about 13.8 billion years ago from a single point of extremely high density and temperature called a singularity. This singularity contained all the matter and energy that would later form the universe as we know it. But what caused this singularity to explode and create the universe? And what was there before the singularity? These are some of the questions that are still unresolved and debated among cosmologists. Some suggest that there may have been another universe before ours, or that our universe is one of many parallel universes that exist in a multiverse. Others propose that there may have been a quantum fluctuation or a vacuum instability that triggered the singularity to expand. Whatever the cause, the result was a colossal explosion that sent matter and energy flying outward in all directions at an incredible speed. This event is known as the Big Bang, although it was not really a bang in the usual sense of sound, since there was no air or space to carry sound waves at that time. It was more like a rapid expansion of space itself. The Big Bang was not only the beginning of matter and energy, but also of space and time. Before the Big Bang, there was no space or time as we understand them today. They merged together with the singularity and started to expand along with it. This means that we cannot look back in time beyond the Big Bang, since there was no time before it. Similarly, we cannot look beyond the edge of the observable universe, since there was no space beyond it. The observable universe is the part of the universe that we can see or detect with our instruments. It has a radius of about 46 billion light years, which means that it takes light 46 billion years to travel from one end to another. However, this does not mean that the observable universe is 46 billion years old. It is only 13.8 billion years old, just like the rest of the universe. The reason why it is bigger than its age is because space itself has been expanding faster than light since the Big Bang. This means that distant objects are moving away from us faster than light can reach us, making them appear farther than they actually are. The observable universe is also not a fixed sphere around us. It changes over time as new regions of space become visible to us and old regions become invisible. Due to the expansion of space, the observable universe is like a bubble that grows larger as we look farther back in time and smaller as we look closer to the present. The Big Bang was not a smooth and uniform event. There were tiny fluctuations in density and temperature that created ripples in space and time. These ripples are called gravitational waves, and they are very faint echoes of the Big Bang that can still be detected today by sensitive instruments such as LIGO and Virgo. These gravitational waves can tell us a lot about how the early universe evolved and what physical laws governed it. One of these physical laws is called inflation. Inflation is a theory that explains why the universe is so flat, smooth, and homogeneous on large scales, despite being so lumpy and irregular on small scales. The CMB is a faint glow of microwave radiation that fills the entire sky and comes from a time when the universe was only 380,000 years old. At that time, the universe had cooled down enough for electrons and protons to combine into hydrogen atoms, making the universe transparent to light for the first time. The CMB is like a snapshot of the baby universe, and it reveals a lot of information about its properties and history. Dark energy is responsible for accelerating the expansion of the universe, which means that distant galaxies are moving away from us faster than they were in the past. The nature and origin of dark energy is unknown. The Big Bang Theory is not a complete theory of everything. It does not explain what caused the singularity to exist or to explode, nor what happened before or during the first fraction of a second of the universe's existence. The origin of the universe is one of the most fascinating and profound topics in science. It tells us where we came from and how we fit into the grand scheme of things. How did life begin in the universe? Is there life elsewhere in the cosmos? How can we detect and communicate with alien civilizations? These questions will be answered in future episodes. Till then, stay curious and subscribe to Story of Times for more exciting documentary like this. And don't forget to leave your comments and questions below. We would love to hear your thoughts and feedback.